So let's look at pairs of circles. So here we are going to look at two circles, right? Now various important points here, right? For example, let's say when there are two circles which touch each other externally, right? Two circles are touching each other externally, a pair of circles which touches each other externally. Now both the circles can be same or can be different. I mean, can be of same radius or of different radius. So when they touch each other externally, right? This is the point of contact. Now let's say the radius here is this is the center O, the radius is R, and this is O dash, the radius is R, and this is a point of contact P, right? This point is P here. So the important point which you need to understand here is the point of contact lies on the line joining the centers of the circle, right? Whenever two circles touch each other externally, right? Whenever two circles touch each other externally, that point of contact between the two circles is on the same straight line which is connecting the two circles, right? Now maybe here, because we have drawn two circles just one beside the other, it's okay, but you take in any way. For example, here is a circle, the other circle is here, this is the other one, right? Now you see the point of contact is P. Let's say this is O dash and this is O. So when you connect the two centers, you'll find that the point of contact P lies on the line which joins the two circles. This looks to be a improper center, right? So if you look at it now, O and O dash is the line joining the two centers, and the point of contact P always lies on the line joining the two centers. Alright, so just remember that the point of contact is collinear with O dash, right? Or we can say O, P and O dash, all these 3 points are collinear, which means they lie on a same straight line. Now let us understand what are the different types of tangents that we get in case of a pair of circles, right? When we have a pair of circles, what are the tangents that we have? So let's consider an example where we have two circles which are not touching each other, right? Which are at a distance from each other. So this is circle 1, and here we have the circle 2, right? So in a given pair of circles, we'll have two types of tangents. One is called a direct tangent, the other is called a transverse tangent or a cross tangent. So let's define these circles first. This is a circle with center O, here is a circle with center O dash. Alright. Now there is a common tangent possible for both the circles, right? Both the circles can have a common tangent, a direct common tangent, right? And there will be two such tangents possible. First of all, two types of tangents. One is a common tangent and the other is a transverse tangent, or you can call it a cross tangent, right? So direct tangent is like this, right? These two circles have a direct tangent. Let me just write. Okay, and there's another direct tangent here. Right, so let's say this is A, B, and this like A dash, B dash. So A, B and A dash, B dash are direct tangents. These are called as common direct tangents, right? Common to both the circles, and these are direct. Now the other category here is transverse tangents, right? Or cross tangents. What are cross tangents? Which are, you know, not straight. I mean, these are like cross. So there will be two cross tangents possible, right? Let us a point. So these are called as cross tangents, right? These two are cross tangents. And these are called direct tangent. This is the direct tangent. This also is the direct tangent. Alright, so that's about the types of tangents that we have in case of a pair of circles, right? So when we have two circles, and now let us look at, let's say the radius here is R1, this radius is R1, and the radius of the second circle is R2, or let's say R and R dash, the radius are R and R dash respectively. And the distance between the centers, right? If you connect O to O dash, let's say from the two centers, the line joining the two centers is of length D, right? This length is this length is d, let's say, the radius are r and r dash respectively. Alright. So how do we measure the length of these tangents? Understand, direct tangent or direct common tangent. These are formulae, you just need to remember, right? Direct common tangent length will be equal to root over d squared minus of r minus r dash whole square. Right, this is the length of direct tangent. And the length of transverse tangent will be equal to root over d square minus of r plus r dash whole square. Get you the point? So two types. So when the two circles are not touching each other, right, when they are distant at a distance from each other, we'll have two direct common tangents and two transverse tangents. Length of those tangents will be given as root over d square minus of r minus r dash square for common tangent, direct tangent, and for transverse tangent it is root over d square minus of r plus r dash whole square, where r and r dash are the radii of the two circles respectively, and d is the distance between the centers of the two circles. Alright, so important formulae, just remember and apply them to get the required answer, right? For example, the radii are given and the distance between the circles is given. He'll ask you to find out the length of transverse tangent or the length of the direct tangent. Just substitute in the right formula. See, the point to be noted here is direct tangent will be longer than a transverse tangent, right? Because see, from in this direct tangent we are subtracting d square minus of r minus r dash. This is a smaller value. Here we are subtracting a larger value. You understand? So it is clear that direct tangents are longer than transverse tangents. Just make a note of this. Alright. Again, maybe this doesn't look appropriate. I mean, it is touching at point E here. Let's say this is point F. This is. It will not touch at the same point, right? B and the two tangents will touch at different points, because at each point we can have only one tangent. So don't misunderstand that both B and E or this transverse tangent and direct tangent will be at a common point. It's not that, right? So EF is one tangent, and let's say CD is the other tangent here, right? C and this is D. So the common tangents are AB and A dash B dash, the direct tangents, right? And the cross tangents are, what do we see here? EF and CD. CD and EF. I think Ajay says, I don't think pairs of circles is important for SSC tier. Well, sometimes we see that we get questions on this. I mean, we cannot just neglect pairs of circles. It is important that you learn all this formulae. See, the challenge is this, right? Geometry is a vast subject, right? It is like, it is not a part of mathematics. It's like a subject on its own, right? And you never know what kind of questions would be asked. So that is the reason I'm trying to cover all the properties. We'll look at a few examples, right? But I'm sure if you follow these properties properly, then you should be able to solve the questions without any difficulty. We can say direct common tangents and transverse common tangents, right? These are also common tangents only. You understand? Common to both the circles. This transverse tangent is common to both the circles. This transverse tangent is common to both the circles. The direct tangent AB is common to both the circles. A dash B dash is also common to both the circles. So both are like common tangents, but two types: direct tangents and transverse tangents. So, you know, again I can say common here. It's like transverse common tangent or common transverse tangent, whichever way you call it. The formulae are important. You should know when it is direct how to measure, and when it is transverse, when it is cross, how do we measure. Alright. Now there may be a case where the two circles are touching each other externally. In that case, what happens? Like the previous point that we discussed was when the two circles touch each other externally. So the point to be noted is when two circles touch each other externally, the distance between the two centers will be the sum of the radius. Yes or no? Let's look at that. Now that we have learned about the types of tangents, let's look at the different cases possible. So when the two circles are disjoint, when they are not touching each other, two direct tangents and two transverse tangents, what happens when they touch each other? Right? What happens when the circles touch each other? See, understand. For example, this is one circle and here is the other circle, right? So this is the center O, here is the center O dash, right? Now if you look at it, this is radius r dash, this is radius r. So I can say d in this case is equal to r plus r dash. Yes or no? The radius of the first circle is r, the radius of the second circle is r dash. The distance between the two circles is nothing but r plus r dash. If you really look at it, there will be two direct tangents. Yes or no? This is one direct tangent, this is the other direct tangent. But will there be a cross tangent? Will there be a transfer tangent? No. Are you going to follow? Do you see a transverse tangent here? Because, you know, what will be the length? Substitute d equals to r plus r dash. If you have to find out the length of transverse tangent, this is r plus r dash whole square minus of r plus r dash whole square becomes 0. Right? So the point is there will be two direct tangents. Now what happens when, so there will be two direct tangents, there won't be any cross tangent as such, right? There won't be any cross tangent. Get the point? We don't have, see, this is common to both the circles, this is also common to both the circles, but you know, so two direct tangents, but transfer tangent is not possible. What happens when the two circles are touching each other internally? In that case, what do you see? For example, let's say this is a bigger circle and there's another smaller circle here, right? Touches each other. So, you know, this is the center and here is the other center. Let's say this is O, this is R dash, and this is center O. This length is R. This is O dash. So for the smaller circle, the center is O, the radius is R dash. For the larger circle, the center is O and the radius is R. Right? Now in this case again, what happens? The distance between the two centers. What will be the distance between the two centers? See, this is complete R dash. This is complete R minus R dash. You understand? I've shown it that side so that you don't get confused. Otherwise, this is completely R and this part is R. So the distance between the two centers is D. Right? How do you measure D in this case? D can be taken as modulus of, or we can say D is equal to R minus R dash. D is equal to R minus R dash. When the circles touch each other internally, right? When the two circles touch each other internally. R minus R dash. The distance is R minus R dash. Alright. Now when the distance is R minus R dash, do you get direct tangents? No, because this is D, R minus R dash whole square minus of R minus R dash whole square. This becomes 0. Right? We'll have one tangent here, right? One cross tangent we can say, right? And when the two circles are congruent, right? When the two circles have the same center, in that case there won't be any direct tangent or any transverse tangent, right? For example, this is a larger circle, center O. With the same center, we have another circle. Right? So this radius is R, or let's say this is R dash, and this is R. Right? Now there cannot be a common tangent in this case, right? Because a tangent has to touch a circle only at one point. Now if that tangent touches this circle, it won't be able to touch this one. Right? Likewise, if a tangent is touching this circle, it won't be able to touch the circumference of the external circle there, right? So in such a case, when the two circles have got the same center, there won't be any common tangent, right? So in a case of pairs of circles, we have two types of common tangents, direct tangents and transverse or cross tangents. The length of the direct tangent is given as root over d square minus of r minus r dash whole square, and that of transverse tangents is given as root over d square minus of r plus r dash whole square. That's it. Radii will be given to you, the distance will be given to you, you just have to find out the length, substitute in the formula and get the required answer. So that's about all the different types of properties related to circles and arcs and chords, secants, tangents, etc.